So for starters, we need to have, let's say, a work breakdown structure. Work breakdown structures are the standard project management organization, whether this is for tasks and normally also for project calculations. To make it simple, we shall use a numbering system for the work breakdown structure, which can be detailed for any topic or any scope that we may require on the project calculation itself. We shall start this work breakdown structure in the numbering 1, of course, and for this one, we shall call it the engineering and project management. The engineering and project management is a broad, let's say, broad scope of the project calculation and will include general costs such as the reference to project management, the site management, the detailed engineering, and eventually some commissioning and other general tasks. As said, we can detail this into more subsets. So the second subset could be the project management, and the other subset could be, for instance, the engineering. Finally, the third one could be the commissioning. You can select these to be center fixed, and then as soon as we start doing this, we already can see some sort of structure for the project calculation and how we will structure this for the remaining costs. So within project management, there are of course some more detail that we can add. So let's pull 1.1.1. We will call this project management at office. 1.1.2 project management at site. Let's start by making some cosmetic changes on this. So cosmetic here and some cosmetic here. These are groupings, so we can make this in a bold. We have already now, let's say, a very basic structure for the project management with some degree of detail. Let's go then to the engineering. So normally in substations we have the civil engineering. Not exactly by this level of importance, but more like for this level of entry in the project. So we can call this civil engineering, and then we'll have the electrical engineering. So make this also for bold. So these are the two main engineering scopes. Usually the engineering of the main equipment itself is within the fabrication of the equipment. So there's no, in most cases, there is no need to make a very detailed breakdown for the engineering of the equipment themselves. But if so requires, we can just simply add more lines here and add the remaining items that we need to add. For the commissioning, we can just keep it simple. So the commissioning, it's the commissioning, and that's it. We have the first structure, which is a general structure, but the first structure and item of the project calculation. Let's leave a few lines blank that we can have some space to work on. And for 2, we'll call this the switchgear or the high voltage equipment. So usually it's quite common to break down the costing based on the importance or the volume of the items from within the scope of the project itself. But it may also be adjusted, or it may follow a template from the company, or in some cases a pre-used template that user already has and can adapt to a specific project. But this is actually quite free to work with. So if the user wants to change this numbering, of course it can be adjusted to their preference. So then within the high voltage switchgear, this one we can make it more simple. So we can just use a two number index. So the first one, we can call this the circuit breakers, the disconnectors, the current transformers, voltage transformers, surge arresters, and this is the high voltage switchgear. As I was saying, I was not reading. So high voltage switchgear. And in here we'll have, let's say, the main main common components in terms of switchgear. We can drag this, then that's it. We'll have the high voltage switchgear breakdown for our project. Next, we can have the high voltage equipment, which is actually all of this is high voltage equipment. This is, let's say, the non-switching high voltage equipment. Let's make a third break, the 3.1 for start. So these can be the power transformers, one of the most expensive items in the calculation. The 3.2 could be the auxiliary transformers, usually for powering the auxiliary services of the substation itself. 3.3 grounding reactors, and I think that's, for now, that's sufficient. Let's make this bold. Okay. Following the high voltage equipment, we'll have the medium voltage equipment, another very important component for that regard. Usually the medium voltage equipment is composed of the medium voltage switchboards, usually used for primary or secondary distribution within the substation, which will then power a set of feeders and actually also the auxiliary transformers, the grounding reactors, eventually some capacitor banks or something like that, usually rated at medium voltage, but for the sake of simplicity we'll keep this only for the medium voltage switchboards. After this we'll have the protection system. The protection system, as already addressed, so protection system is actually the brains of the substation itself. The remaining equipment, such as the breakers, disconnectors, high voltage equipment and so on, these are dummies in the sense of their intelligence as a sole equipment, so they all need a protection control system that shall detect the fault, trigger the operation of the equipment and ensure the safety of the substation. So the protection system is normally composed of the following: the protection and control cabinets, or the protection and control, the SCADA system, a metering system, and the telecommunication system. Telecommunications, for simplicity. Let's add some items here, and that's it. Following the protection systems, these all need to be powered somehow. We have already seen that the auxiliary transformers are the ones which can provide power to the auxiliary systems of the substation, but we need to have low voltage power supplies. And for that we'll use item 6, which is the auxiliary systems. And the auxiliary systems are usually composed of an AC-DC converter system, which is actually the UPS, the uninterruptible power supply. We have the DC AC 400 volt distribution boards, DC 110 volts distribution boards, and a couple of miscellaneous supplies. Let's start at 6.1, drag this a little bit, make this bold, and I would say that we are starting to have the majority of the bulk equipment already detailed. Following this, let's start to add some services component. So item 7 will be our services. The services part, in a very simplistic form, it's composed of the civil works and the erection works. This is quite simplistic because in most calculations both the civil works and the erection works have much more detail. So for the civil works you have the landfill preparation, the soil preparation, the platform execution, construction the building, construction of the outdoor foundations and so on. But as a structure or as a preparation for as a dummy calculation, this is sufficient for now. But of course, as we have seen on item 1, we can add more detail, a third level, a fourth level, and we can add more detail to the services component so that we are able to properly analyze each of these components, compare offers from sub-suppliers and so on. So as of now, let's keep this as civil works and erection works. And having this, I think that we have already, let's say, a very basic, yet with some detail, costs calculation for a project substation. Let's start the cleanup process. So we need some space here, just as a This actually depends a lot on the user. Me personally, I do prefer to have some spacing in between the items, just to make it easy to understand the structure. Of course, we can use the letter size, the spacing between lines and so on to adjust this. If there is a template, we usually follow the template. If not, we can follow more or less the preference on who's making the project calculation. Now, as soon as we have this structure, this very basic structure, we'll start to add the columns. So project calculations are usually organized by columns. So on the lines, what you detail is, let's say, the tasks or the components, the supplies and services that you want to procure and execute and so on. And then column-wise, you start to work on the quantities, on the pricing, taxes, selling price, fees, gross margins, and so on. So to keep this simple, let's start with the first one, which are the units. So regardless of the item, you always have to select the units and then the quantities. So because we need to know where's the potato, where's the orange, so we need to follow a structure where you show the units and the quantities for each item. Afterwards, we have the unitary cost. So each item should have a unitary cost and a total cost. Usually, of course, the total cost is a calculated column based on the quantities and the unitary cost. Now we can start to fill this out. To approach components such as the project management, we can work in units of months. So we can select this, my unit is a month. And the quantities, let's say the project itself goes for 12 months. And I have my manager on site for like half the time. So let's say 6 months. Then we can estimate the cost. Let's say I have 10,000 euros off-site and 5,000 euros on-site. Usually this is more of a senior person and the site manager is more of a junior person, but it may depend as well on the complexity of a project. Let's readjust these columns. So let's pull command 1. Let's adjust these columns to show numberings with 1,000 separated, because now we are looking at values, so it's easier for us to see this like in numbers. And then, as I said, the total cost is just this one multiplied by the unit cost. Let's add this here, and we have the total cost for these items. We can drag this, and now we start to have a brief idea or a short idea on what's the cost of the project itself. And we can continue this. For the civil and the electrical engineering, this is usually a global value. So you procure a company to make the services for you, then you select the company and they give you, let's say, a lump sum offer to execute the entire engineering scope that you have defined with them. So this means that the units here are actually a global value, which is a very common acronym used for this. So this means that the quantity in the end it's only one, because there's only one civil engineering. Let's say that this costs like 50,000 and electrical engineering is also 50,000, so we can make both the civil and electrical engineers happy with this. Copy these columns, then we have the total cost also for the two engineering components. Continuing, you have the commissioning. The commissioning can also be understood as months. To make it easy, let's copy this line, paste it here. Commissioning, let's say that this costs or this takes more or less 1 month, and we also have a senior engineer here making the final commissioning of the substation. And with this, we are starting to see a little bit of a costing structure for the project. But how much is this in the end? To start to have an idea of the subtotals of the project, we actually suggest to use the subtotal function. To start to have some idea of the subsets of the project, I recommend that you always use the subtotal function. The reason to do so is because it's a more robust approach. Usually it's very common to have engineers to using the sum function, which is easier, more straightforward in most cases, but there's also some issues with it. One of the most critical, I think, it's that it's easier for us to lose track of the lines, because sums have sum themselves. So if you have a subsum here, and then we make a sum here for this subsum and this one, this will sum both the values and the sum of those values. And if you use the subtotal, you can easily do this, so you don't need to worry with overlapping subtotals. So in the end, because we can make broader ranges and not to take care, just select the items which are needed to be there, it's easier for us to debug, because if you have an overall subtotal which shows you X and you have two subtotals which show different values, you can already even visually understand where there's an error, and with sums it's much more difficult. So let's try making a subtotal here for this. The subtotal itself has several functions we can use. The most common, of course, is the sum itself, so you can select 9 for the subtotal and then select the range that we want to go. So let's say that I want to make a subtotal for the chapter 1. I can go to here. The reason I go to here very close to the line 2 is because if you need to add some lines here, you do not need to worry to adjust the range of the subtotal, so it's already taken care of. So let's go this and you are done. Okay, another way to do so, you can even drag to here, because if you place a subtotal here for the next chapter, this won't sum. So in that case, you make sure that even if you add lines right on top of this chapter, they will still be dragged on and be included in the first subtotal. So we can see here, this is the first chapter. Let's add some color to this. The first chapter, there's engineering and project management, and we have already a cost for this. Let's follow the same structure for the high voltage switchgear and high voltage equipment. So equipments, of course, are in most cases measured in units. So I can select all of these lines and this one here as a unit. Okay, Control Enter, and then there's units. And let's imagine a very simple line transformer bay for a substation. So you have one breaker, one disconnector, 3 voltage and 3 current transformers, so one for each pole, and 3 surge arresters. And now let's place some dummy costs for this. So this costs 10, this may cost a little bit less, the current transformers far less, the CTs and VTs many times have the same price, more level. This is less expensive. And okay, we have some costs for the high voltage switchgear. Let's copy the formula that we have already created here, and that's it. Of course, we can always drag these lines below and to do something like this, but we need to take care of these zeros in between. So we could add some formulas to check if there's a value here, just make an if condition, which is very straightforward. But as we are now, just to keep all formulas simple to make it easy to work on, let's keep this as it is. Now that we have the cost for the high voltage switchgear, we can do the same approach. So we can go here, let's write again subtotal 9 and drag up to the next chapter. And that's it. You have already the cost for the high voltage switchgear. A little bit of coloring, and that's it. We can add some lines here to just keep it more or less visually the same. Keep it structured, keep it clean. Then let's move on to the high voltage equipment. So as we said, we have a line transformer bay, quite a simplistic design, one transformer, one auxiliary transformer, and one grounding reactor. To make a difference in the price, let's say that the power transformers are a much more expensive item. The auxiliary transformers usually not so much. Of course, these are all dummy costs. This is just for the sake of the training. Of course, this is not related anyway to any specific project, but we can go into that detail if you just leave me a note on the comments, and I will support you with some example costs for this sort of installations. Then, as soon as you have these costs, let's do the same. Let's make a subtotal here, 9, select the range, and we are there. A little bit of coloring. Then we can do this for the entire project. We can do this for the medium voltage equipment, for the protection control and auxiliary systems. So for the sake of simplicity, units here, and units here. We all have one subset of each, so you can just copy the numbers or write them, it's the same. I will add some dummy costs here. and I will add also some dummy costs here. Copy the formulas. Okay. Then add a couple of subtotals also to this. So just make it easy. I can also copy this, of course, and readjust the scope. Just make sure that once you make the copy, you always adjust right after. So don't copy all subtotals and then try to arrange them, because oftentimes you need to adjust something in between, then you forget to adjust the ranges. Then you'll have a problem that most probably will take you much more time to debug once you are working on the final tuning of the calculation. So let's make this also aesthetically the same. So I will bold these topics here, and I will also color them to follow the same structure as we had before. Okay. So finally, services. Services are usually also, if you do not have a breakdown on the tasks, this is actually also a global value for each item. So you select a contractor which will do the entire civil works of the substation, and you select another one that will make the entire erection works of the substation. Let's select here some dummy costs also. So this is 200 and this can be 150. Copy the formulas to these two cells, and that's it. We have already the breakdown and costing of a substation as a very simple example, but we need to know how much it costs in the end. So I'll create here another line. I really like to have colors separating things so you can have a visual interpretation of the information and of the data. And then what we'll do, we'll use the subtotal function again. So subtotal 9, and let's select the range of all the positions up to here. Okay, enter, and that's it. We have an overall cost for a substation, not very bad, I can say. Fine tune, fine adjustments, and okay, you have something that you work with in terms of project calculation. Thank you and see you next time.